Good morning, all of you. In today's class, we will see some basic definitions and theory part so that you will understand the further concepts. The first one is a rigid body. What is a rigid body? So see, a rigid body is nothing but a body whose size and shape will not change whatever the amount of force we have applied on it. Got it? So its size and shape should not change whatever the force applied may be. For example, you know that spherical bob, pendulum bob, yeah. So its size and shape will not change even application of force. But actually, this rigid body, perfect rigid body, does not exist in the nature. Got it? So let's see what is this rigid body. A body whose size and shape cannot be changed however large the applied force may be. However large the applied force may be. Right? Next one, as I told, there is no perfectly rigid body in nature. There is no perfectly rigid body in nature, and closest approach is what? Diamond. Closest approach is diamond. Got it? So the rigid body is one whose size and shape will not change whatever the force we have applied, and there is no perfectly rigid body in nature. Closest approach is diamond. Okay. Next one is deformation force. What is that? Deformation force. Now see, deformation force means which deforms the body, or you can say the force who is responsible or which is responsible for changing shape of the body. Got it? Understand? For example, suppose this is a ball, and now this boy is just applying the force, and then this ball shape is changing like this. Yes or not? So whatever the force this boy has applied, this is what deforming force we can say. Understood? Right? The force which is responsible for changing shape and size of a body, you can say in simple language. The external force which changes the size, which changes the size or shape, or both, we can say size and shape of a body without moving as a whole. Or no need to write this, just enough. The external force which changes the size or shape, or both of a body, this is what your deformation force. Next one is restoring force. Restoring force. Restoring force is what? Deforming force means the one who is responsible to change the shape and size of a body. Yes. Restoring force is what? Restoring force is what? Suppose now this ball is a rubber ball. Okay, rubber ball. And by applying some force, you have changed its shape like this. But immediately after some time again, this ball comes back or regains its original shape and size. That is because of restoring force. So internally, the force which is responsible to bring or to give back its original shape, that is what your restoring force meaning is. Got it? So here restoring force is this. Got it? So I'm writing that. The internal force, the internal force which restores the size and shape of the body, the size and shape of the body when deformation force is removed, is called restoring force. Means immediately when you are pressing the ball and you are removing that force, again it regains its original shape and size. That is because of this restoring force. Understand? So note down this. Note down fast. You can add one line here, that is, this force is responsible for elastic nature of the body. Okay, which force? This restoring force. Okay, let's move ahead. Yes, finished or not? Note down if did not finish. Okay, next, elastic behavior of solids. So this is just theoretical concept. I will just explain. You see, elastic behavior of solids means in solids what we are having, atoms or molecules. Okay, and they are bonded together by intermolecular forces. So when you are applying force on that solid, it will deform, means it will change its shape. So what happens, whatever that intermolecular forces are there, they will get displaced, or that molecules will get displaced from their mean position. And as soon as you are removing the force, then again they will come back to their original position, and hence they will attain again their original shape and size. Okay, so just intermolecular force means what? Because of position of atoms or molecules. Got it? So next one is elasticity and plasticity. Elasticity and plasticity. I will give you one table so that it is easy to keep it in mind. Elasticity and plasticity. So see what is elasticity and plasticity. First, generally I will explain. You take one ball in one hand and take putty in another hand. Okay, right? Now you press this ball, rubber ball, and leave it. What will happen? It will regain its original shape and size. At the same time, you press this putty and leave it. What happens? It will not regain its original shape and size. So that is what plastic, and this ball is what? Elastic. The one who is regaining its original shape and size, that is what? Elastic body. The one which does not regains its original shape and size after removal of external force, that is what? Plastic body. Clear? So let's see in detail. See here, the property of a material, the property of a material by virtue of which, by virtue of which it regains its original size and shape. It regains its original size and shape when when deformation, or external, you can say, deformation force is removed. Deformation force is removed. Got it? For example of this elastic body, that is quartz, diamond, steel, rubber, etc. Quartz, diamond, steel, rubber, etc. Okay, you can see the steel scale nowadays. So many of you might have been that steel scale, 30 centimeter scale. You just bend it by applying some force and then leave it. Automatically, it will become straight only. Yes or no? That's why it is elastic body. Got it? Rubber already you know. Okay. Next one. As I said, there is no perfect elastic material, perfect elastic material in a nature, and diamond is what? Or quartz, we can say. Quartz is a nearest quartz is nearest approach, we can say. Got it? Now here also, what is this plastic body? Now just what you have to do, does not we have to use here, because it will not regain its original shape and size as soon as you are removing the force. Got it? In which bodies? Plastic bodies. So the property of a material, the property of a material by virtue of which it does not regain its original size and shape when deformation force is removed. When deformation force is removed. Got it? Example, put it off, chewing gum. You know everyone this, है ना? बालों को भी लगाते हैं कुछ लोग, वैसे नहीं करना है. ओके, बेंच पे भी लगाते हैं. डोंट डू दैट. Then soldering lead. Soldering lead is there in our lab. I will show you. Okay. Next one. Again here also, no material is perfectly plastic. No material is perfectly plastic. And but putty is nearest approach. T is nearest approach. Okay, this is what elasticity and plasticity. Can note down fast. Okay, let's move ahead. Next is stress. I will give you just one tree diagram and you will get to know how many types of stress. Actually, these are just by definition, I am just describing them. Stress is what? First of all, stress is nothing but restoring force per unit area. Stress is what? Restoring force per unit area. Restoring force per unit area. Restoring force per unit area. And stress is equal to capital F by A. Okay. Restoring force per unit area and stress is equal to F by A. Now I am giving one just like types of stress. Okay, so that you will understand what happens in which stress. What happens in which stress. Okay. Tensile stress. Next is compressive stress. Next one is normal stress. Just wait, I will tell you this. This is like a definitions, okay? But we will keep it in mind like a flow chart so that it is easy. Normal stress. Then next is tangential stress. Next is shearing stress. Next is volume or bulk stress. Volume or bulk stress. Volume or bulk stress. Okay. Now, what is this tensile stress? This compressive stress, normal stress, tangential stress, shearing stress, and this volume or bulk stress. Let's see. So first, this is tensile. Tensile means what? Tensile means what? Stress developed due to elongation. What is this? Stress developed due to elongation. Stress developed due to elongation is what this tensile stress is. Next one, this is compressive stress. This is what? Due to compression now. Yes or not? Due to, just I am writing due to compression. Compression means what? When you are compressing something. Due to compression. Stress developed due to compression is what compressive stress is. Next is normal stress. In this what? Force is normal to the surface. Force is normal to the surface. Force is normal to the surface. Next, in tangential stress, force is tangential. Force is tangential. I will give a diagram also for this. Just wait. Force is tangential in this tangential stress. Next one, shearing stress changes the shape of the body. Changes the shape of body. Changes the shape of the body. That stress is called shearing stress. And here what volume stress means? Obviously what? Normal stress which changes it changes volume of the body. Normal stress which changes the volume of the body. Got it? So in this tensile stress, you see if length is getting changed, what is getting changed? Length. In this stress is due to compression. So here elongation की जगह पे क्या होता है? Compression. This is normal stress. This is tangential stress. This is shearing stress, and this is volume or bulk stress. So this is also normal stress only. Again, volume or bulk stress is again also how? Normal only. Got it? Clear? That is this and this one are normal stress only. Again, type of this only we can say. Got it? Next one, note point I will give below. Note point. Stress the bottom of hollow cylinder of hollow cylinder of inner radius r1 and outer radius r2 inner radius r1 and outer radius r2 is equal to mg by pi r2 square minus r1 square. This is nothing but F by A, and this is your stress. Yes, sir. How it came, sir? If I will draw like this cylinder, you can see here. This is inner and outer radiuses. But I will draw one diagram that you will understand perfectly. So whatever this radius is there, no, this one, this is what R1 is, and this outer radius is what R2. And if you want the stress at this bottom of this cylinder, then this is force by area. So force is nothing but weight of this cylinder, that is mg, and area is what? This is hollow, no, this part is hollow. So pi r2 square minus pi r1 square. That's it. So this is what your stress at the bottom of that cylinder. Understood? So note down this and just revise this carefully. Okay. So note down this and let's stop here for today. Bye.